Hello and welcome to INE's CCI Service Provider version 5 lab course. For some of you who do not know me, my name is Rohit Pardasani and I am going to be your instructor for this entire lab course. Something about me, I have been in the industry for about 19 years now and I have 5 CCIs: route switch, security, service provider, voice and collaboration. So what exactly are we going to learn today? Well, the first thing we're going to learn today is basically the main 2 core IGPs that you would be tested upon in your lab exam, which is OSPF and ISIs. So this course is all about the basics of OSPF and the basics of ISIs. So let's first look at OSPF and let's just focus on OSPF as of today. So if you look at OSPF is a link state routing protocol, and it's probably one of the most famous routing protocols which you would see in the industry. If you look at from an enterprise perspective, the most famous would be either EIGRP or OSPF. These are the 2 common routing protocols that you would use in an enterprise environment. But if you look at from a service provider segment, it would either be OSPF or ISIs. ISIs being more preferred because of its extensions and more scalability. But again, OSPF is the most common and easy to deploy. So when you configure OSPF or when you activate OSPF, which can be activated on the interface or under the routing protocol using the network statement. So when you activate OSPF, it basically starts listening for hellos on that interface. And as you know, OSPF sends hello packets on 224.0.0.5 and it starts listening on that interface. And once it forms a neighbor, or once it starts listing the hello packets and it finds a neighbor there, they start exchanging information which is used to build our link state database table or your LSDB table. The LSDB basically contains the list of all the information, all the links, the metrics, the router ID of the neighbor, what links are connected, and probably the different types of LSAs, whether it's LSA1 or LSA2 or LSA3. Now, once this database is built, the routers are basically going to run the SPF algorithm, which is the shortest path first. It runs this algorithm to calculate the best path, and the best path goes in the routing table. As you know, OSPF runs the best path algorithm and finds the best path based on metrics, and the metric of OSPF is cost, which is based on the reference bandwidth. The default reference bandwidth is 100 meg. It can be adjusted, or in fact you should adjust that in case if you have faster links, because OSPF treats a fast Ethernet and a gig port as the same, because the reference bandwidth by default is 100 meg. So you should change your reference bandwidth to incorporate faster links. Now, if you look at the OSPF has 3 different kinds of tables. We have the neighbor table, we have the topology table, and then we have the routing table. Now, neighbor table, everybody has heard of the neighbor table. What does neighbor table contain? It basically contains a list of all the neighbors on that segment. So if I do a show IP OSPF neighbor, I would see all my neighbors, on which interface they are connected, and what's the router ID of that neighbor. That's your neighbor table. Then we have the topology table. I mean, technically it would be wrong to say it's the topology table, because topology table, you always think about EIGRP, because EIGRP has a topology table. But when I use the term topology table, it's kind of like EIGRP with the slight difference that here it's called as the database or the database table or the link state database, which is where all the LSAs are there and all the link information are stored. So to view the database, you can give the command show IP OSPF database, or you could do a specific command by giving show IP OSPF database, maybe router LSA or network LSA or summary LSA with a specific network that you are looking for. That's your database table. And then finally, we have the routing table, which basically contains the best path. OSPF does automatic load balancing if the metrics are same. So how is the routing preference defined? So a router will always look at the prefix length first. If the length is same, it looks at the administrative distance. If that is same, it does not go to metric. It first looks at the type of metric, or which is either if I've received the route as an O route or an OIA or an external route. So if I receive routes from two neighbors and they both are sending me intra-area route, which is O, then I would look at the metric. If the metrics are same, then it does automatic load balancing. So routing table always contains the best path. Now, one thing you must remember about OSPF is that OSPF has one most important role. Everybody needs to maintain the exact same copy of the database. You and me within the same area cannot have different database. You and me should have the exact same information. So everybody maintains the exact same copy within the area. Between areas, your database and my database could be different. If we were in different areas, it could be different. But within the same area, you and me cannot have different information. That's the most important rule of OSPF. So what's the goal for creating areas? See, these are just topics that I'm just skimming through. These are just basic, just to give you an overview of OSPF, which you probably already know. So coming back, why do we need to create multiple areas? And why is single area not preferred? So if you look at single area, yes, it's easy to configure, it's quick and fast, but there are some problems with single area. The first most problem is that you cannot summarize, which means if I had to reduce my routing table, I could not summarize within the area. Again, the reason you cannot summarize is because the basic rule of OSPF is that everybody needs to maintain the exact same copy of the database. So if I have 4 routes in my database, and if I summarize and send you, you would have only 1. That breaks the rule of OSPF. That's why you cannot summarize within the area in OSPF. That's one problem of running single area. The second problem would be too many LSAs. It's not scalable. So imagine if I increase the amount of routers within the area and the number of links within those routers increase also, what's going to happen? There's going to be too many LSAs and there would be a flood of LSAs. The performance would be degraded. Your convergence would be affected. So these are basic problems of OSPF when you run them as single area. Yes, if you have 4, 5, 10 routers, there's no point running multi-area. Would you ever be tested for multi-area in the lab exam? Probably yes, probably no. The chances are pretty slim because yes, you would never be tested for stub or totally stub or not so stubby. This is more towards the CCI enterprise. As far as CCI service provider is concerned, you may be tested for multi-area, maybe area 1 for AS1 and area 2 for AS2 and maybe area 0 in the center. Maybe you're tested for that, but you would not be tested for stub or totally stub or not so stubby. So it's always nice to know how to configure multi-areas. So obviously by you configuring multi-areas, you are creating area boundaries which now allow you to do summarization. So if I have multiple areas, I can do summarization on the ABR. So one thing you must know is that if you are creating multi-areas, then all areas need to be directly connected to the backbone area. And they have to be connected through the ABR. So area boundaries are going to be created using multiple areas. So if you want LSA 1 of area 1 to not go to area 2, then you would create a boundary by an ABR which separates LSA 1 of area 1 and LSA 1 of area 2 through an ABR which has the backbone area running on that router. So let's look at the most frequently used packets of OSPF. Obviously you know that OSPF sends hello packets. But besides that, there are some OSPF packets that you should know about. The first one is LSA. This is the most important packet of OSPF, which is the main method of communication between two routers. This LSA or this packet mainly contains the fundamental information about the topology. For example, the router ID of the neighbor, who is advertising, who is the originator, what links he has, what's the metric, is it LSA1 or LSA2. So there are different types of LSAs where a router could receive LSA1 or 2 or 3 or 4. In fact, there are 11 different kinds of LSAs that you should know about. In fact, in some of our other videos, we would be talking about all the different types of LSAs. In fact, all 11 different types of LSAs and their functionality and their differences. The second type of OSPF packet would be a link state database packet. This packet basically contains all the updated link state information which is exchanged between two routers. As you remember, if you remember that everybody needs to maintain the exact same copy, so the link state database is what all routers within the area need to have the same information. Now, what happens if my information of my database and your information of your database is different? If it's different, it breaks the rule of OSPF. In that case, what do? Well, if my information is different, I am going to send you a link state request saying, hey, your information and my information is not the same. Maybe I'm missing some networks. So here is a request. Can you send me your information? That's your link state request. Once I send you that request, you are going to send me back a link state update, which basically tells me that, okay, here is your update and here is the missing piece of information that you did not have, and here is that information. That's my link state update. And then finally we have the link state acknowledgement. So if I send you a request, you should acknowledge that, or if I send you an update, you should acknowledge that. That's my link state acknowledgement. Now, if you look at different types of routers within an area, there are different types of routers within an area. We could have an ABR, which is an area border router. If you remember, an ABR is that router that connects to multiple areas, but one area needs to be area 0. That's an ABR. Only an ABR generates LSA3 or LSA4. Maybe in some cases LSA5 also, if maybe he was connected to a not so stubby area and he was a translator for type 7 to type 5, or maybe if he was also an ASBR. So an ABR is the one which connects multiple areas to each other through the backbone area, which is area 0. Then we have the autonomous system border router, which is the ASBR. This is the router which is redistributing other protocols into OSPF. So maybe a router that connects to an ISP, and maybe he's learning routes through BGP, and maybe you're redistributing certain routes from BGP into OSPF. He would be called as an ASBR. Then we also have a DR, designated router. A DR is normally selected in a broadcast segment. So if you have a broadcast segment to reduce the amount of LSA floods, a DR would be elected. A DR is going to be elected based on the priority. If the priority is same, which is by default 1, higher is better. So if the priority is same, it goes to the next criteria, which is router ID. Again, the device which has the highest router ID wins, and he would be elected as the DR. All other routers would be DR others. You may have a BDR. BDR is optional, but DR must be present if there is a broadcast segment. But BDR could be optional. So in case if the DR goes down, the BDR gets promoted as the DR and a new BDR would be elected. So let's have a quick look at our configuration. I have already configured two routers, one iOS XZ and one iOS XR. I have already configured them to establish OSPF adjacency. We will look at our neighbor table, we will look at our routing table, we will look at our database and verify if there is a DR being elected in the broadcast segment between them. Alright, so let's have a quick look at our iOS XE. So here I have router 6, which has been pre-configured with OSPF. The process ID is 1, the router ID is 6.6.6.6, and all its interfaces are running OSPF in area 0. We can always give the command show IP OSPF interface brief to check which interfaces are running OSPF. So here I have all of these interfaces which are running OSPF, and as you can see here, on this interface there is a BDR present. On gig 1.56 there is a DR present. So because this is a broadcast segment, there would be a DR election. You can always verify your network type with the show IP OSPF interface. Let's say gig 1.56. You would see that the network type is broadcast. Because of that, there would be a DR election. So you can always verify your DR by doing a show IP OSPF interface brief, or you could do a show IP OSPF neighbor. Even that would show you all your neighbors on all its link, and would also show you if there's a DR present and who is the DR and who is the BDR or DR other. Similarly on iOS XR, if you do a show run router OSPF, here is where I have OSPF configured, and the commands are a bit different from iOS XE. So here we have router OSPF 1, we define the router ID, area 0, and then activate OSPF on all its interfaces. If I do a show OSPF neighbor, again you should be able to see all your neighbors with the show OSPF neighbor, and you can always do a show OSPF interface brief, which will again show you what is your priority or your neighbor's priority, which area you belong to, what's the cost of that link. All that information you can see that from show OSPF interface brief. You can also do a show OSPF interface and the interface number to identify what's the network type, the hello and dead, because as you know in OSPF the hello and dead should match, otherwise you would not establish OSPF adjacency. As far as the database is concerned, you can always do a show OSPF database. This just gives you all the information about all the different types of LSAs. So as you can see, I only have one area running right now, area 0. So this is my LSA 1, which is the router LSA. I have my network LSA because it's a broadcast segment. So there would be LSA 2 because a DR is present. So you would see LSA 1 and LSA 2. You would not see LSA 3, 4, or 5 because I don't have inter-area or any ASBRs. Now, so let's do a quick preview of the prerequisites for OSPF to establish neighborship. What should be the same? They should be in the same network, they should be in the same area, they should have the same network type, same hello and dead, MTU should match, and the stub flag should match. If authentication is configured, then authentication should be configured on both sides. I hope this video was informative to you, and thank you for viewing.